I will start off, I'll read the problem to begin for you guys. The height in meters of a projectile shot vertically upward from a point 2 meters above the ground level with an initial velocity of 24.5 meters per second is h equals 2 plus 24.5 t minus 4.9 t squared after t seconds. So we have a formula for height and a lot of background on how they got the formula, but the important thing is the formula. So part A, find the velocity after 2 seconds and 4 seconds. What do we do?
We found the derivative of the equation.
Yep. So remember, we've done these before. We have position. The first derivative is velocity. What's the second derivative?
Acceleration.
Acceleration.
Do you want me to write the original problem too? Or
Sure. That might be helpful for Cole when he goes back to watch this.
It's really thick.
Oh, if you touch the pen again, I think it'll get thinner.
What's that button? Sorry.
No, it's okay. Try it now. No? All right, just try it.
Just roll with this one.
Normally it gets... That's annoying. It's not on nothing this one. Okay, well, guess we're just gonna... There we go.
Oh, oops. Oh my gosh.
All right, so that was our original. Do you have to plug in the 2 or take the derivative first? Derivative first. What would happen if you plugged in the 2? You get 0. Good.
Okay, so that's the derivative. And then when you simplify it,
Good. So they did the product rule within that. You could have also just done power rule, but we get the same answer. So all good options. All right, so now we need, that's our velocity. So now to get that at 2 and 4 seconds.
so to do that we plugged in the 2 and we plugged in the 4.
Mm-hmm.
When you plug in the 2 you get 4.9.
Good. Do you guys need to see the work on how they put that in? What's the difference between a positive and a negative velocity?
It's going up.
Right, positive is going up, negative is going down. Okay, good. Part B.
Do you want to do B since you found that one?
There's no way to show it because I just did process of elimination through a calculator
Okay,
because I didn't know how to find it.
so, well here, let me ask this. You just said it's going up and going down, right? So here is your maximum. What's going to be true about the derivative at your maximum? Mm-hmm. So what you're doing is finding the point when your derivative is 0.
You know, I thought that. I was like, you know, it has to be this, but then it never went click, and I just started typing.
So if we work that out, we get 24.5 equals 9.8 t. Divide by the 9.8. So that's at 2.5 seconds. So we hit our maximum height after 2.5 seconds. All right, now you guys can do part C.
Do you want to write it?
The handwriting ain't best.
You can do it.
Maximum height.
So we know when we have a maximum height. So how do we actually find the height?
You would just plug it in
Mhm.
to the,
To the original equation, since that was our height function.
out.
Good. All right. Part D. When does it hit the ground? If it hits the ground, what is our height? 0. So this is asking when the original is equal to 0. So Anna, how do we do that?
This one we did the quadratic formula.
Mm-hmm.
Oh, sorry.
No, it's fine. If you need to erase a
Erase
flat
it.
hand, will also erase. Either way.
Sorry, this is really sloppy.
No, it's okay. Opposite of b plus and minus square root of b squared.
Gosh, how do you write on this? This is like really hard.
That's why I make you guys do it every now and then. You appreciate me more this
Oh, yeah.
way. Minus 4ac. All over 2a.
And then after that, we got
So technically they got 2 answers, but when you did them on the calculator, one of them turned out to be negative. Can you have a negative time? No. So we knew it had to be the positive one, so it hit the ground after about 5.08 seconds. All right. So that was part D. All right, part E. With what velocity does it hit the ground? So I'm asking about velocity. That is our derivative. Yeah, so now we are plugging that 5.08 into the derivative that we found in part A.
No, I only did 5.08,
That's fine.
so.
And we would expect a negative here if it's coming back down and hitting the ground. We know it's coming down. Good. All right, any questions about their problem? Okay. Thank you, guys. I think we can get through maybe one more. So our chemistry problem. All All right, Boyle's law states that when a sample of gas is compressed at a constant temperature, the product of the pressure and volume remain constant. P times V equals C.
So we had to find the rate of change of the volume with respect to pressure, and so that's just your derivative, but you want to get your V on one side. We had to get our V on one side, and then
Was it UV?
yeah, P of V equals C.
C.
So then we ended up getting V equals C over P. And then we had to find the derivative for V, so then we did the quotient rule. And we ended up,
Probably should have went that out.
Yeah, so when they did this quotient rule, they did low, D high. C is a constant, so what's the derivative of a constant? 0. Minus high, D low. P is the variable, so the derivative of P to the first would just be 1 over low squared. And so that's how they got the derivative to be negative C over P squared.
and that was our rate of change. And then from there, it asks, a sample of gas is in a container at low pressure and is steadily compressed at a constant temperature for 10 minutes. Is the volume decreasing more rapidly at the beginning or at the end of the 10 minutes? Basically, we just explained that it would decrease more rapidly at the beginning because there's more gas to compress at the beginning, and it's easier to compress the gas whenever it's not already like super compressed.
What Bryson just drew there is what the graph would
The
look like.
pressure increases, your volume rapidly decreases.
Mhm.
Since it's a fraction, it, yeah.
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 It's decreasing because it's a negative,
Yeah.
and as P gets larger and larger, it's just getting closer to 0.
Yeah,
So
because your
it's
C is gonna like always stay the same, so it's gonna be
Yeah,
like
you're constant.
-1 over like a half, all the way to like -1, like 10, 1,000.
Mhm.
Yeah.
Any questions for them? Okay. We're going to stop here so we're not rushed tomorrow. So tomorrow, our econ group will present, and then we're going to see what progress you guys have made on that biology problem, and we'll talk through it and work through it together. So some groups started because they had time. If you haven't, that's not a big deal. The second page of this is the actual assignment. You are welcome to start. It will be due on Thursday. So we're working on this today and tomorrow. Homework isn't due until Thursday.